In this lesson, we're going to begin our discussion about conic sections. Before we can really understand what a conic section is, it's important that we understand what a cone is. The definition there might help, but I believe seeing what a cone looks like will be very, very important. Now, a conic section is basically a shape that is formed when a flat surface meets a cone. If you're wondering what section there means, it's just you making a cut through a particular object. The conic in the word conic section there is just simply meaning we're referring to a cone. So under conic sections, we're just looking at some new figures again. We've had triangles, quadrilaterals, polygons, and now we're going to have a new group of shapes which we call conic sections. The most common kind of conic section is one where you have a cone as shown on screen that is cut at an angle, and then the top piece is removed and you have a shape that you can see in the 3D figure. This shape here is what we're calling a conic section. This type of shape will be constructed just by some information that has been given. There are several types of conic sections that we have, and we're going to look at them in this introductory video. Before we can start looking at these different types of conic sections, it's very important that you always remember that if we place our cone in a particular position, it will basically look like a triangle. And so whenever you see a triangle like that on screen, just know I'm talking about a cone. We know that a conic section is a shape that is formed when we cut through a cone. So the different kinds of conic sections that we're going to have are brought about when we cut at different angles. The first is when we have cut the cone such that the surface that we are forming after the cut is parallel to the base. When we look at the top of the cone that we just cut, we can see a particular shape. This shape here has a special name and it's known as the circle. Obviously, we've drawn multiple circles in the previous lessons about tangents. Even in triangles, we drew some circles. So a circle is also a conic section. You only have a circle if you cut your cone parallel to its base. An interesting thing is when we rotate these cones, even though you cut it parallel to the base, the shapes that you can see are going to differ. So it's always a rule of thumb that when we're looking at these shapes with an intent to name them, we should look at them perpendicular to the surface that they are forming. What that means is, if we want to really know what type of conic section this surface is forming, we should look at it at 90 degrees. The arrow here shows the direction in which we looked at for us to be able to see this type of conic section. The next type of conic section is the ellipse. We've seen the ellipse just as I was introducing the conic sections. When we cut our cone at an angle and look at the new face that has been formed at 90 degrees, we're going to look at a conic section that is known as the ellipse. Right now here I've got an object which is a cone that has been cut through at an angle. It's like I'm standing right in front of it. You'll notice the ellipse looks like it's longer horizontally. But if we just start moving around this cone, you will see that the ellipse is kind of changing the orientations. That's kind of a problem, and this is where I emphasize that whenever we're looking at these shapes that are formed when we cut a cone, we make sure that we're looking at the cone at a particular angle. That angle should always be at 90 degrees with this surface where we've made the cut. And when we look at that angle, we can see the actual shape of that conic section. So when we see a conic section that looks like this, a circle that has been stretched, we have an ellipse. At this point, we know how the ellipse looks like. It's important that we consolidate the information about the ellipse. By now, we know that for us to have an ellipse, we need to cut our cone in a way as shown here. The ellipse is gotten when we look in this direction, and it's shown in this picture here. This shape that we're seeing is what we're naming as the ellipse. Pertaining to the angle we need to cut at, we can have a range of angles, but we should always remember that when we cut our cone, we should never cut through the base. As long as we obey those simple rules, the conic section we're going to have is going to always be an ellipse. So we can have any angle. Common angles you see are 30 degrees, 60, 45 degrees, and the angles won't be very big. Apart from that, there is additional information we need to know about the ellipse. For us to be able to construct any ellipse, we should be able to understand the terminologies of major axis and minor axis. The major axis is the distance between the vertex of an ellipse. It is the longer distance between the vertices here. The shorter distance here is called the minor axis. As you can see, the naming of these axes is very easy to show which of the distances is bigger than the other. Major is the longer one, minor is the smaller one. Apart from these distances, it's also very important to know what a focus is. The focus will be created using half the major axis, and when we start constructing the ellipse, that will be covered. But it's very important you also know that an ellipse has a focus. These key things should always be remembered when we're talking about the ellipse. These might sound like very small, simple properties, but they will be very helpful as we begin constructing. We refer to things like the major axis of this ellipse is so much, the minor axis of an ellipse is this, and then we can construct. The next type of conic section we'll be looking at is the parabola. One thing you should note about the parabola is that the way we're going to cut our cone is in such a way that it will be parallel to the side of the triangle here. So we've agreed this triangle is representing a cone, right? Now, if we cut our cone in such a way that the path that we follow is parallel to one of these sides, so it can be this side or this one, the conic section that we're going to have is going to be called a parabola. A quick way to remember this fact is that parallel and parabola both have para in their beginnings of the word. Similarly, like we did for the ellipse, we're going to have multiple views of the cone when it has been cut for us to have a parabola. When we look in the direction of the arrow, such that we are perpendicular to this surface that is just formed, what we're going to see is a parabola. A key thing you notice about the parabola is that it doesn't close, it doesn't form a shape like a circle. It's open on this end. The next type of conic section we're going to cover is known as the hyperbola. A hyperbola is very similar to a parabola. The main difference that you will see is that when we cut our cone to form a hyperbola, the path that we follow is not parallel to what seems as our side of the cone. If you were to compare the slopes of the lines that are forming these sections, you notice that it's kind of like a hyperbola has got a line that is drawn with a gradient that is more than that of the parabola. But all that aside, for a hyperbola, you just need to remember that it will be more slanted. Then this line will never be parallel to this side of our cone. After the cut, what we'll be looking at is something like this. But I bet you appreciate it more when you look at it visually in a model that is three-dimensional. This is how our hyperbola looks like. Key things to notice is that our hyperbola will be having a much larger opening than our parabola. These points for a parabola are more close together. For a hyperbola, they'll be very far apart. It's very important to remember even here that our hyperbola is pictured well enough, or the best way, when we look in the direction of the arrow. And when we do that, we'll see something like this. This is our hyperbola, just this shape here. With these simple concepts about conic sections, I'm very sure that you will understand them much more better when we begin constructing them and drawing them.